Assalamualaikum and good evening. This is our 7th video. Okay, in the last video, we have done the transmission heat gain by calculating the glass, wall, and ceiling heat there is gain from the transmission. Okay, so for now, in this video, we are going to calculate internal heat. Okay, in the building or the space that we have to cool down to install the air conditioner, the heat also generated from the people, from the appliance, from the light, from the lamp, from the refrigerators, TVs, computers, and so on. Okay, so for this example, we refer to the numbers of people. In the information that is given in the example, we know the occupants in the building are expected to be 30 workers. So we put it 30 into the form 30 persons. Okay, so the 30 persons have to multiply with the value in the table 9 to get the heat gain from internal heat. So we refer to the table 10, heat gain from people. Okay, and also referring to the building activities, degree of activities. In our building we have general office, so we have to assume there are standing and walking, or walking seated, or standing walking slowly. Okay, that's how you decide which is the activity in the building happens. Okay, I think in our problem we have the office workers, which is suitable for the office typical application, and referring to this one, we have sensible and latent, and also 78, 75, or 70. Which one we have to choose? Okay, let's see the information that is given. Okay, the target condition in the building, we want to get the 75 degree of Fahrenheit. So in that table 10, we have to choose the value only from the 75 Fahrenheit. Okay, so now we have only one problem. We choose sensible or latent. Okay, we have to choose both, but in the difference column in the form. So refer back to the form. Okay, for now we are going only to calculate sensible heat first. So in the table 10, choose sensible, not latent, not yet to be chosen. Okay, sensible, office 75 degree, so we have 245 value. Put it 245. Okay, use your calculator. 30 times 245, you will get 7350. Okay, let's go to the next step. We have to calculate the lights. Okay, sometimes to get the BTU for the lights, we are going to get the value of area times table 1 and times type factor based on the material of the bulb or light, and times conversion 3.4. Okay, 3.4 is the conversion of kilowatt to BTU. Okay, this one is the constant, so no need to change it, just put it 3.4. Okay, before that, let's refer to the building information. Building information. Okay, lighting. Okay, the information is given for fluorescence. The light or the bulb is made up from the fluorescence. The material is the fluorescence, not LED, not incandescence, just fluorescence. And the heat generated from the light is 4 watts per square feet. Okay, in watts. So put it in the form for what? An area is 1500. Okay, type factor, you will have to refer to the reference table. This one. If the light or bulb is incandescent, you don't have to put the type factor value. But if it is fluorescent is famous to give waste heat, so we have to multiply with 1.25 type factor. So put it 1 to 1.25 here, and the conversion 3.4. As I said before, is the conversion from watt to BTU. Okay, so let's calculate it. 1500 times 4 watts per square feet, and times 1.25 type factor because it is fluorescence, and times 3.4. You will get 25,500. Wow, it's a lot of value there. Okay, so let's go to the next step. We have to calculate all the electrical appliances that generate heat in the building. Okay, refer to the building information. Do we have another appliance in the building? Okay, yes, we have 30 computers, 50 watt per computers per PC. Okay, just computers in the building. 50 watt and quantity 30 computer, right? I forgot already. 30 computers. Yes, 30 computers, 50 watt per each. Okay, type factor. No, we don't have type factor for the computers. But if you have the efficiency, we can times with the efficiency. So that's the real life calculation. But for this example, we don't have to calculate to put the type factor. Just to put 1 is okay. Okay, 30 times 50 times 1 times 3.4. Once again, 3.4 is the conversion value, conversion constant, to convert watt into BTU. So 30 times 50, you will get 1500 BTU. Okay, so we almost done this internal heat. So in the end, we have to calculate all three values for the people, lights, and equipment. Okay, 7350 plus 25,500 plus 1,500. Okay, the summation is 34350. Okay, so we have done A, solar heat gain, B, transmission heat gain, and C, internal heat. All these sections contribute to the total room sensible heat. So we have to sum up all the values from the total A, total B, and total C and put it here. Total A, total B, total C, and put it here. Okay. 7665.81 plus 17395.5 plus 34350, and the value is, oh sorry, 59,411.31. Okay, safety factor 10% of the 59,000. So you will get 5941.131. Okay, so the room sensible heat, total room sensible heat, in this form we call it RSH, room sensible heat. You have to sum up 1 and 2. Okay, refer to this one. So the value is 59411.31 plus 5941.131, and the value is 65352.44. Okay, this is almost the most part. Put it, highlight there. This value we will use it later. Okay, let's continue to the D section. Okay, D section is the outside air sensible. Okay, outside air, because we assume the air conditioner in the building will be used the centralized or package unit that will use the outside air and cool it to get the targeted condition. So we have to consider the area from the surrounding that will be sucked into the area by using AHU, air handling unit. So let's calculate the D section. Okay, outside air. Okay, CFM stands for cubic feet per minute. Okay, this one we have calculated at the early of our video. Okay, this one, the ventilation. You consider 3 factors before: people, square feet, and air change per hour. So to choose between these values, you have to pick the highest value, which is 450. Okay, 450 is due to the 30 people. So copy paste 450 into this column, 450. And then you have to calculate the BF. BF is bypass factor. Okay, generally, to get the value of BF, we have to refer to the table 12. Table 12. This one. Okay, but before that, make sure you check the building information first. If the value of bypass factor is given or not. Okay, so this problem we already have the BF value 0.2. Okay, put it into the form. Where is my form? Okay, 0.2. And time 1.09. This is the constant value, so you don't need to worry that. And time with the temperature difference. Also similar to the previous part in the B, transmission heat gain. Temperature difference in our problem is 17, which is the difference between temperature of outside compared to the inside of the room. So put it 17 Fahrenheit there. Okay, so complete the 450 times 0.2 times 1.09 times 17, and you will get 1667.7. Okay, so to get total effective room sensible heat or ERSH, we have to sum the value of this one with this one. Okay, so 65,352.44 plus 1667.7, and you will get 67,020.14. Okay, this value is very important. So this is much less important. Make sure you put it highlighted. Okay, so that's all for this video. In the next video, we are going to calculate the part of D, room latent heat. Okay, stay tuned and wait for my next video. Thank you and bye bye.